David, you founded Plus in 2016. This is not your first rodeo. You found an enterprise software company, a digital media company, a gaming company, and then Plus. Why did you found Plus in 2016? What did you see in the market, and why was that the next step for you?
Yeah, Grayson, it's great to be here. Thank you for inviting me on. I'm an engineer by training, so I studied computer science and electrical engineering at Stanford 25 years ago. I happen to be an entrepreneur. I'm always passionate about utilizing technology to solve real world problems. And I've been doing this for the past 20 years. I started a few companies, took one public, and sold the other two. In 2016, along with a few of my co-founders, and they happened to be my former classmate at Stanford, we observed a general trend where we believe there's going to be an AI boom. People have been working on artificial intelligence for decades, but this time around, it's very different. So we founded the company as Plus AI Inc. to symbolize the positive impact that AI technology is going to bring to the society. We really think this is going to be a transformative technology in the coming decades. And the reason we pick autonomous driving space as a problem to solve is because it's among one of the most complex engineering problems of our generation. I remember when I was back in school, robotics and autonomous driving, it's really cool stuff to work on. But 20, 25 or 30 years ago, the technology, just from a software and hardware point of view, wasn't there to make a truly autonomous driving vehicle to be commercialized. But back in 2016, we think that it is going to happen in the coming 10 years. That's why we made the decision to work on it. And the other side of founding Plus is when we pick the specific problem to work on in autonomous driving, we decide to work on trucking because it's going to make a huge economic and societal impact for our generation. And that was basically, how we decided to get started, and the rest was history.
I've said this for many times, years now, and we saw the president-elect Trump came out and said it, and they said, "Sir, how did you win?" He goes, "Groceries, groceries, groceries." Where if you look at inflation, we could have another bout of inflation could ramp up again. Autonomous trucking, from an economic standpoint, can lower inflation, lower the cost of goods, and have a really good positive economic benefit for the economy. You're right about that. I want to stay on the AI track because 2025, we're going to blink and 2025 is going to be here. And you turn on Bloomberg, you turn on CNBC, open the Financial Times, Wall Street Journal, AI, 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 AI. It's everywhere you turn. And now we're starting to see, since the election, a huge excitement around autonomy. Do you feel that 2025 could be that moment where autonomy goes mainstream?
Absolutely. Actually, it is already mainstream in some parts of our country. In particular, if you go into San Francisco, you do see a lot of driverless vehicles running around. And most recent news is looks like driverless cabs are actually, in terms of market share, overtaking some of the other mainstream ride-hailing options. So it's happening. People have been talking about this for the past 10 years. Finally, it's here. And the thing about technology adoption is once it gets there, the scaling is going to happen really, really quickly. So I do think we are standing at the cusp of the inflection point, and the next 3 to 5 years are going to be really, really exciting.
They're going to be tremendous. I think there's going to be awesome. When you look to the next 3 to 5 years, we're at the inflection point with robotaxis, you clearly stated. Waymo is scaling in San Francisco, gaining market share from Uber and Lyft. They announced they're going to Japan on a quote-unquote road trip. You, myself, our listeners and viewers know they're going to expand there at some point. I'm going to publicly say 27. Over the next 3 to 5 years, do we reach that inflection point on the autonomous trucking side where you're hauling freight, your customers are hauling freight? We reach that inflection point like, wow, this technology is real and look at the positive impact it's having. Do we get that inflection point?
Absolutely. So if you look at overall in the industry, the trucking industry are primarily, in terms of trucks, are primarily provided by a few large global OEMs. It's Volkswagen's Traton Group, it's Daimler, Volvo, Packard, and Europe, IVECO. So these 4 or 5 large OEMs provide, majority, over 99% of the trucks on the market. And all of them have been working on autonomous solution for the past 10 years or so. And they've all made announcement and recently some progress in launching the fully driverless trucks in the coming years. They've made public announcement in the 26 or 27 timeframe. And we've been working with a few of these large OEMs for the past few years to make that happen. So it is going to happen, in the next 2 to 3 years.
You have a global partnership with Traton. So for our listeners who are not too familiar with trucking, that includes the Scania brands and the Navistar brands. You're currently testing with them in Texas, I believe it's San Antonio, and you're also testing with them in Sweden. How did that partnership come about? And when you entered into that partnership from the discussions on day one, was there always a focus on global and not just operating in one country?
Absolutely. So our partnership with Traton Group is global. Traton Group is Volkswagen's commercial vehicle trucking group. It encompasses brands like Scania, in the US, Navistar International. In Germany, it's MAN and Volkswagen buses. So we've been working with Traton for many years. I started with discussions and exchange of ideas, and then later on turned into collaboration on some small aspects of the overall autonomy stack. But we found that it's fantastic to work together as two companies that we have high alignment on our technology roadmap, our commercial roadmap, and most importantly, our team culture. And this led to a full-scale collaboration on the global census. And it's fantastic to work with a leading global OEM like Traton to push forward the adoption of driverless trucks. In addition, we also have been collaborating with other global OEMs, including Hyundai Commercial Vehicles as well as IVECO. So one thing I'm most proud of is that all of our partners greatly appreciate working with us, because I believe that we are always in position to want to make our partners successful. And I think they appreciate that.
Hyundai is getting very interesting. They announced today, or it's reported in the Nikkei out of Japan, that they're partnering with Samsung to build autonomous driving chips. It'll be really interesting when those get commercialized. It's great news for the market because it eliminates the reliance on Taiwan Semi. On the Hyundai side, Hyundai has been investing a lot of money in hydrogen fuel cells. Is that the technology you're going to run on, or are you going to run on the traditional diesel trucks?
Yes, so hydrogen cell trucks, they have a major initiative to deploy and to grow that business in the US. And they have a vision of these hydrogen fuel cell trucks should also be automated. And we are their autonomy technology partner to enable that.
You're the partner, which is awesome. How does it work? Do they integrate the Plus technology on the factory line? Do you retrofit them? How does that partnership work?
It's a collaboration in terms of jointly develop a factory installed product. So, we work on collaborating on the hardware spec side. We work on the software side. So in terms of the division of work, we're more responsible for the software stack in terms of providing the intelligence system on top of the vehicles. And our OEM partners are more responsible for providing the vehicle platform in terms of the actuation, in terms of the sensor hardware setup, and manufacturing of these trucks. And then our OEM partners are, in many cases, also responsible for operating these trucks for fleets.
Will you make recommendations to your OEM partners of where the sensors should go or the type of compute that works best with your software?
Yes, that's what we do. So we provide a reference design, and we work jointly with our OEM partners to optimize those designs. And then they will take that design and manufacture the vehicles based on our recommendation.
With Traton, you're doing a similar joint development as well to what you're doing with Hyundai?
Yes, that's what we do together. They have hundreds of people working on this program, and then we have a joint project team together. So the way we look at it is not just autonomous driving software, it's the overall system that we're collaborating on to design.
Wow. So I just want to clarify this for a lot of the viewers don't really know. You stated you have 2 OEM partnerships, one with Traton and one with Hyundai. Is that correct?
3. And then the other one was IVECO.
You're the only one right now with 3 OEM partnerships in the market from an autonomous trucking standpoint. What does that unlock for you from a business standpoint? Because to me, from an investor standpoint, you're eliminating risk for me, where if one, say, relationship goes sour, okay, I still have 2 more in the race. That unlocks a lot.
I think people get comfort from that, but the way we look at it is we're the technology enabler in this whole ecosystem. To make autonomous trucking work, it not only takes the software stack, it also up and down the entire value system, entire ecosystem. All of the participants need to work together to make it a reality. So if you look at L4 autonomous truck, right? So you have the software on it, you have the sensor suites, you have the vehicle actuation, you have the vehicle platform, but also you have the carriers. You need to integrate that truck into the operation of the fleets. You have the road infrastructure operator who provide the road infrastructure for these autonomous trucks to operate on. And then there are a lot of things you can do on the infrastructure side to make the driving safer, to make autonomous trucks to be able to be deployed more scalably. So all of these partners can work together to make it a reality faster. So we work with many of these leading players in each individual value chain segment. So for instance, we have partnership with many of the tier one suppliers in providing the most up-to-date and redundant actuation system. For instance, we announced a partnership with Bosch on that, and then we're working with many others as well. On the OEM side, as I mentioned, we work with three of the largest global OEMs, on the vehicle platform, integrating and making the autonomous trucks. On the fleet side, we've been working with Amazon, and we've been working with DSV, which is one of the world's largest 3PL based in Europe, on integrating our solution into their overall logistics systems. And on road infrastructure, we have a partnership with Transurban, who is the largest road operator in Australia. So it's about working with the entire ecosystem to make it happen.
Transurban's making a lot of noise. If you look at Australia, those roads go on for a very, very long time. And sometimes if you go into the outback or you go into northern Australia, you're in the middle of nowhere. If you look, staying on the infrastructure track, the Japanese government has been very vocal. I believe it's the transportation ministry. I'm not sure of the exact way how to properly say it. Is investing in dedicated lanes for autonomous trucking in Japan because of the driver shortage that they're very public on, because the economic impact negatively it's having on that. Is Japan on your radar? I'm asking from an infrastructure standpoint, since the government is actively investing in it from an infrastructure standpoint, and they're actively putting laws in place to enable autonomous trucks to scale?
Definitely, we've been looking at Japan. We actually have done some work in Japan. We've collected some data with our partners in Japan. We have test vehicles there, actually. So in terms of commercial traction, at this point, there's nothing to announce publicly. But Japan is an important market for us.
I knew everybody was going to end up in Japan at some point. And my wife and I were having dinner last night. She said, "You've been saying Japan for years." And it's another validation, David, of what you said, that I'll give my wife credit. She said I was right. So I'm going to be good and give her credit there. From a commercial standpoint, so you're operating with three OEMs, you're operating in multi-countries. How does the software adapt? Because these countries have different cultures, different customs, and for your business, they have different rules of the road. How do you adapt the software, those different rules of the road in these various countries?
So we have a global development process. So for instance, Traton is a global OEM. They have offices in the US, here, in Germany, in Sweden. And to collaborate with them, we have developed and IVECO is European based as well. So to work with our partners, we have developed a global development processes. And it's almost like, around the clock, right? Because we've got engineers here sitting in Silicon Valley. We have engineers in Munich, in Germany, and our partners have engineers in all different places. And then, so first of all, we develop that engineering processes where we can collaborate globally. The other thing is that we can collect data globally, and then we can do testing globally, right? So right now we're testing in Texas and Sweden, along with our partner in Traton. And that gives us a very diverse set of data in terms of driving condition, in terms of traffic laws, in terms of weather condition. And as we all know, the intelligence of the system, the level of intelligence actually have a lot to do with the diversity of the data that you use to train these systems. And by being a global company, being a global development effort, this provides us a lot of advantage in making the system to be more robust, more generalizable.
Do we ever get to a point where there's too much data or too much noise in the data that you're gathering?
Perhaps potentially eventually we have too much data. Right now, I think the problem or the question, the challenge the overall industry is trying to address is how do we get to have more usable data, and how do we reduce the cost of utilizing those data? And we're actually constrained mostly by getting useful data into the system. So that's one of the engineering challenge or the problem that I think everyone in the industry is trying to tackle. And we're on our way there to solve that problem, but it is one of the issues that we need to tackle.
Is it being done manually today? Did you develop an algorithm? Is it a labeling system to determine what data is useful and what data you can get edge cases in that data? Is that being done, labeling being done manually, or how are you doing that process?
Yeah, so historically that was all done manually, and then pretty quickly, we figured, that's not really scalable, and then we developed an automated process to process data, to filter data, to get the data to instill knowledge into the data automatically, and then use that data, useful data, to train our system. So, by automating the entire process, we reduce dramatically the cost of getting useful data.
When you get the useful data, you update the plus driver. How do you determine what amount of data goes onto the truck that enables it to drive? Because if you're going to take your whole data set and put it onto the truck, it's going to be very expensive and very heavy to run.
Yeah, so we utilize our entire data set to train our internal foundation model, if you will. It's a large, big model that has all the intelligence in it to understand the physical world, to make decisions. And then obviously we can't run that model in the vehicles. So we have a set of technology to distill that knowledge, to distill that intelligence into these smaller driver models. And then we can run more efficiently on the lower powered compute system that's situated on the vehicles.
Low powers, where it all has to go. Do you see low power becoming a trend for autonomous driving in the future? Because when you get low power, the economics start to get very, very good versus high power.
Yeah, I think the general trend on technology is always, higher performance, lower cost, and lower power, right? When I say low power in the vehicles, but we're still talking about hundreds of watts. But if you're looking at the data center now, we're talking about orders of magnitude more power, right? So it's all relative. Hundreds of watts actually provide us tremendous amount of compute, compared to even just 10 years ago. And we're able to do what we do today, and we're standing on the cusp or inflection point of actually having autonomous driving be a commercial reality, all because of that progress on the performance on the compute side, on the algorithm side, and all of that. Over the last 10 years, there has been a lot of progress.
And it's shrinking years and years ago, probably about a decade ago, maybe a decade and a half ago. Mercedes-Benz hosted me at their R&D facility in Sunnyvale. And this is when they were testing the S550s, 500s. And this was very, very early. Their autonomous driving program came back. And I said, well, this is good. You're making progress. They said, no, we're failing. And I said, well, excuse me? They said, no, we're failing. Open the trunk. And of course, we opened the trunk, and you know this. The thing is just compute. I said, well, that's normal because this is the technology developing. No. Our customers cannot put their golf clubs in this trunk. We cannot sell and commercialize this technology. And fast forward to today, if you were to get into a Waymo, you could put your golf clubs in the back of a Waymo. On the truck side, do we follow that similar track where if you get into an autonomous truck today, depending on which one you're in, some of them have it on the side, some have it across the bottom. It's a very large, I'll use the term container. Over time, do you see that container shrinking as the technology gets better and better and better?
Yes, I mean, today, even in our system, the compute system itself is actually quite small. It's no bigger than a suitcase. And the reason for that being, the overall industries keep driving down the size and the power consumption of these compute systems, partly because of space constraint, partly because of power constraint, but most importantly because of the scalability and reliability of these systems. As we found out in the general engineering field, that the smaller it goes, the more reliable things becomes. Because if with a larger system, more high power system, you need multiple times of that for heat dissipation. And these mechanical systems for heat dissipation usually first goes into trouble if you have, and then if you have a problem with the overall heat dissipation and power distribution system, your entire system fails. So by making those smaller and more compact, the system would improve their reliability dramatically.
I never knew smaller equals more reliable.
Look how your
Yeah, that's what I'm thinking about. It's a lot more reliable than Apollo 13. But I digress on that standpoint. So is it a fair statement to say over time that you imagine the hardware that's running the Plus software on the trucks over time will continue to get smaller and smaller, and as it does get smaller and smaller, it'll continue to be more and more reliable?
Yes, absolutely. I mean, that was the vision we had when we founded the company back in 2016, right? We were thinking like, it's going to take a lot of effort to make the autonomous system work. And where should we focus our energy? And so we took the view where, the industry over the ecosystem is going to make progress on various aspects of this whole stack. People are going to advance the compute system dramatically over the next 10 years, right? Which turned out to be true. If you look back in 2016, what are the compute system we use? I mean, these are called the large NVIDIA machines, right? The smallest one is kind of like a Xavier system. If you look at the system we have today, they're much smaller and much more compute in it, right? So we relied on our partner, like in NVIDIA. We announced a global partnership with NVIDIA back in 2019 to work on in-vehicle autonomous systems. And we rely on them to push forward on the hardware side. We work with our sensor providers, right? So, we think, I remember the first capital equipment we got was a 128 line LiDAR. It was $80,000. And it weighs like a ton, right? And then, but we envision that in 10 years, the cost, the performance, and all of those things will literally follow Moore's law. And it turns out to be the case. So those are the areas that we think the industry, our partners are going to make tremendous progress on. The area that we focus on developing is the intelligence side. We found the company as an AI company, and we had a vision that, on the software, on the intelligence side, our paradigm will be a data-driven paradigm where, we think, over time with more data, with quantitative more data, it's going to eventually cause a qualitative leap. And it looks like that's turning out to be true.
I got to stay on the quantum trend here because I've been reading the papers and I'm fascinated with the Alphabet or the Willow chip. What impact, I know this is theory now, so I'll say that. What impact in theory could that have on autonomous driving?
That's a little bit beyond me. I'm following that as an amateur in that field, but that's extremely exciting, obviously. I tend to personally focus on what I understand and what I have control over. And then for these fields, I try to learn and try to be literate about it. But it's a field that's beyond me at the moment.
At the moment. See, you said the key thing there, at the moment, because with your background in computer science from Stanford, I give it a matter of time. Next thing you know, I'm chatting to you, say 6 months from now, and we have a 3-hour conversation about the Willow chips. Because you have the intelligence in your brain the very same way that the Plus driver has the intelligence there in the software. A lot. So we have the quantum breakthrough with Willow, that's changing. And then in the industry, there's a very large movement towards vision only on the car side. Do we get to the point where we see vision only on the truck side as well?
So first of all, don't think, so we take a very first principled approach in terms of figure out what the solution is. And I know from the industry conversation point of view, there, people like two camps, right? You have the vision only camp, which is championed by the Tesla of the world. And then you have called it the HD map LiDAR camp. If you look 10 years ago, that's the Waymo or from the DARPA days, right? So you have these two camps. And it's easy to construct a narrative. It's like, red versus blue. And then, you kind of compete on who's right. And the engineer is never like that. Engineer is about, identify the problem and figure out what's the best approach to solve that problem. And if you look at the problem, what is the problem in autonomy? It's really, at the core of it, it's a human intelligence problem. How do you have a machine to understand what's going on in the world? And how do you have a machine make decisions about what's going on in the world and make predictions about what's going on in the world? So to tackle those two problems, it's whatever technology can help us solve those problems, we should adopt them. And 10 years ago, the DARPA guys or the Waymo, that school of thoughts or original that tech stack, it's about utilizing HD maps and utilizing lidars to understand the world, to perceive the world, because we have ready technology to do that. And then that basically created a whole solution for autonomous driving. But at the same time, we realized back in 2016, almost 8 years ago, that cameras and deep neural networks can also be utilized to understand the world. And there's tremendous growth on that technology over the last few years in providing better and better performance in terms of helping understand the physical world. Right? So right now, if you look at the solution, the best performing solution for autonomous driving, it's actually a combination of all of that. So the LiDAR HT technology has also grown quite a bit. So performance got a lot better compared to many years ago. And the vision technology has certainly grown a lot, right? Become significantly better than 8 years ago. So in the cases to provide the best, highest performing system, the safest driving system, our belief is you should utilize all of them, right? If they can provide benefit from a cost benefit point of view, if it makes sense to use it, you should use it. So we are not a school of vision only or LiDAR only. We're of a school of best technology should always be utilized to provide the solution. So certainly we utilize vision technology. We have lots of deep networks, and we have a lot of deep neural network scientists in our company pushing forward on that. We use sensor fusion. We use not only LiDAR, not only cameras, we also use different type of radar systems. And we evaluate all kinds of different sensors out there to utilize the best technology to help us solve these problems.
You're taking a practical approach. Is that a fair statement? You're taking a very practical approach?
We're taking a practical approach. We're taking a very first principle approach to solve these problems.
You're solving the problems. You're taking the practical approach. Where and when does redundancy enter the picture? What type of redundancy do you have to build in for the Plus driver to perform at its optimal capability?
That's exactly what we want to use the multiple sensors. That's providing a level of redundancy there, right? So if camera doesn't see clearly or that doesn't provide the level of confidence that requires, then we have LiDAR, we have radar. It's like a human driver, right? You have eyes, but you don't have ears, right? And a human do have different modes of perception. So why should a machine have that too, right? And then not only on our intelligence system on the software side, but also to enable true driverless operations, we need redundant drive systems, right? So today, in many of the vehicles, when you have a human driver or human safety driver, the human is the redundant system. In a truly driverless environment, you need another set of redundant system, a safety driver, right? That's there to watch the overall operation or the performance of the primary system and provide that failover for the system. So we need redundant steering, we need redundant brakes on these vehicles to make that happen. So redundancy is really at the core of everything we do.
Is that where the OEM partnerships and relationships come in, because they're incredible engineers that can build this redundancy for you on the factory line?
Yes, that's where they're integral and unmissable part of making autonomous driving work.
There's a lot of questions from Wall Street. Can you not go fully autonomous drive route without redundancy? In your opinion, do you need redundancy to go fully autonomous?
Absolutely. It's a must-have.
Because then if you don't have it, then in theory, you're taking a risk.
You're taking a huge risk, yes. So I think we can do many of the demos and pilots, right, with the system we have today without redundancy. But to have commercial deployment and to scale this technology commercially, redundant system is a must-have. I think that's a responsible thing to do. And then we take that as a core value of our company we are here to provide benefit to the society. We should provide a technology that actually benefit people, right? And we should do the responsible thing.
If you do the responsible thing, you build trust. And so if I'm on the road with my child, or there's another family on the road with their children, and they see your truck, they know there's trust there because you built the system the right way. How is it as an autonomous trucking industry as a whole? Do you feel that are the best ways to develop and maintain that trust? Because at some point, your vehicles, your trucks will be operating with your partners. I'm sorry, you're not the operator. I want to clarify that for our viewership here. You're not the going to operate it, but when your partners are operating it with your technology, how do you build and maintain that trust?
So first of all, I completely agree with you. Trust is at the core of everything we do, which is why we think we should only go driverless when we have sufficient confidence and data to really have that belief that our driverless truck actually drives safer than a human driver. And I do believe today, if you look across the industry has evolved quite a bit over the last 10 years. Now the remaining players in this industry are all very responsible players, right? Starting with Waymo and many others. And because time is actually the tell sign of everything, right? And the industry right now are basically driven mostly by a few players who share that value. Right? So all of us, I believe, are operating under the assumption that we will only deploy driverless, driver out vehicles when we truly believe that our system is at a performance level that's safer than an average human driver.
Because that's the bar that yourself and the rest of the industry holds to, then the industry becomes extremely successful.
That's what we're working toward.
You're testing today with safety drivers and safety engineers. Are they testing the redundant system as well, or will that come at some point in the future where you'll put a safety driver in the redundant vehicles and test those?
Yeah, so today we're doing pilot tests in Texas and Sweden with the safety driver. So 2025 is going to be all about validation. We're going to validate our safety cases. We're going to test our minimal risk maneuver situations. When we get into those situations, the vehicle need to be able to handle those situations and get into a safe place. 2026 is when the redundant drivetrain platform is going to become commercially available. So that's the timeline our OEM partners have been providing us. And we're going to be testing the driver out operations in 26. And then, beyond that, 27 and beyond, we will be looking at starting to deploy these systems commercially.
It's not far away. 26 testing, 27 plus, to give you wiggle room there. You begin commercial operations. When you begin commercial operations, what's the business model going to be?
So our business model is to enable our OEM customers and partners to deploy these driverless trucks. So we get a revenue share or revenue royalty share out of that. And our OEM partners and customers, they all have different models, but it's mostly a consumption-based model where they get paid certain fee per mile of providing that truck as an operation for the fleets.
Well, this is a hypothetical, but for instance, your partner Traton, could you see them operating a freight network powered by Plus?
Hypothetically, that's one of the mode that we will be operating under. Yes.
And then you could take that, or if they sell it to, say, Acme Fleet, and Acme Fleet's going to operate, I'll just say, a fleet of 1,000 trucks. They'll go to their Traton dealer, they'll buy 1,000 Navistars, then they'll buy a subscription to the Plus driver per truck.
Yeah, so that's kind of the model. So today, if you look at the industry, we have one of the challenge that we're trying to help address is the driver shortage problem. Fleets have a lot of things that they need to transport from point A to point B, hub to hub. And today we have 80,000 driver shortage in the US. That's about 4 to 5% of the overall industry. Like containers are not getting shipped because we don't have enough drivers to drive the truck, right? So in the future situation, it's about these fleets will go to International or Daimler or Volvo. They will be asking them to lease them a truck plus the virtual driver on it to help them transport that container or those containers from point A to point B. And then they will pay them the same way they're paying the trucks today, which is on a per mile basis, a per mile fee, right? So they will just, get these, trucks with virtual driver on them and pay them, at a similar rate. And, and these virtual trucks or virtual driver trucks hopefully will be able to deliver those containers more on time, safer, and at a more economical scale at a lower cost.
And then Plus operates as, for simplicity reasons, you operate basically software as a service?
Yes, so we will be the software behind that. And we operate this as a software as a service. And then, the OEMs will be, sharing part of that transfer fee with us.
At the end of the day, then you become a global autonomous trucking software developer at the end of the day. And that's fascinating because you're not going to have to manage the assets, the depreciation, the liability, the insurance. You're just going to ship software to your partners and customers.
That's what we want to focus on doing, because that's where we believe we provide the most value add. I think others in the industry has been doing manufacturing, asset management, fleet services, maintenance, these things at a much more efficient scale and much more experience than we have done. At the core of our company, we are an AI technology company, and we want to be able to create that technology, to be able to provide that technology, to enable our partners to make autonomous trucking a reality.
You're going to make it a reality as AI advances. They're saying, oh, it's plateauing. My opinion, it's not plateauing. We're just getting started. And I can reference Mr. Eric Schmidt, the former chairman and CEO of Alphabet, has made similar comments. And he wrote a really good book on it recently called Genius. As AI improves, gets smarter, do you leverage those new technical breakthroughs into the Plus AI model to make your model more redundant, more scalable, and an overall better driver?
Absolutely. I don't think we're in this thing on our own. If you look at the overall industry, billions, actually not billions, like hundreds of billions of dollars has already gone into this industry, right? And we should ask, this feels and probably is at the same scale when internet happened, how much transformative force has it brought to the society. This is basically, that again. So, we take a look at, what happened in those times and where should we, leverage or build on top of what others have invested heavily on, right? And then figure out, what's the problem that we can contribute to solve, and utilize whatever's available out there to solve the problem.
Could we get to a point with AI where if you take the Meta's Llama model, the Anthropic's Claude model, the Google Gemini model, or the ChatGPT models, where an autonomous driving stack could be built upon those models?
That's one of the hypotheses we have. If you think about the intelligence system or these models, right? These foundation companies, they build these foundation models based on all the foundation data we have on the internet. So contained within these models are the intelligence that you can derive from the data that you're able to use to train these systems. But on top of that foundation intelligence, for specific domains, based on the design of your domain-specific model and enabled by domain-specific data, you can accumulate domain-specific intelligence. And that's how we think about solving this general problem, which is you have these foundation intelligence that are provided by these foundation models. And we build domain-specific foundation, call it plugins, to solve some of these part of the problems. So for autonomous driving, it's really at the core is to solve the driving intelligence problem. And to be able to do driving intelligence, you probably need physical ability to understand the physical world. So you need physical intelligence, right? And then you need understanding of the traffic laws. So there's certain behavior intelligence and rules that you kind of build into your model. So that's how, from a technology point of view, how we think about solving this problem.
Another thing you're doing, you're public with, you have an L2 system. You're gathering a lot of real world data there that I'm assuming then you're feeding into your models to enhance them. I've said this publicly, not all miles are created equal. To me, there's more value in real world miles than sim miles. What advantage is that giving you? Because I'll just say weekly, daily, you're getting fresh new data to enhance and finely tune your models?
Yeah, so data volume is important, but more important is the diversity of data. Not all data are created equal, right? Real miles are dramatically more valuable than simulated miles, and diverse miles are dramatically more valuable than just average miles, right? So, I mean, if you run a truck in a stadium, in circles, additional data doesn't give you anything, right? But if you are able to gather data in diverse environments all over the US and in Europe and in Australia and in Japan, those data give you significantly more, dramatically more knowledge in those data. And that's what we're able to do with our deployment, with our technology. So we have data throughout all of the states in the United States, and we have a lot of data in Europe, in many of the major countries throughout the European corridor. And then we have data in Japan, which drive on the different side of the road. So those data contained within them are the intelligence that we can use to train our model, to make our model smarter.
Data unlocks knowledge. We all do it. We just ask ChatGPT a question, you learn something, you gain knowledge. You're gaining knowledge by operating your trucks globally, and that's refining your model and making them smarter. It's going to be exciting to see where Plus goes as you ramp up towards 2070, begin commercial operations. David, in your opinion, what is the future of Plus AI?
In my opinion, so first of all, I'm extremely excited about where we are today. It's been 8 years of work, and we're finally at a point where we are at the cusp of really truly commercialize this technology, and we are leading this transformative change in the trucking industry, and we're doing it with our partners, with Traton, with IVECO, with Hyundai, with many other additional partners throughout the entire ecosystem. And I truly believe that in 20 or 30 years, I want people to say, ain't all trucks like this in the first place? And I want to know that my team at Plus helped to make that happen.
Your team's going to make it happen. We are going to have that scenario. We're all going to question, why are we on the road with a human driver when we could be on the road with an autonomous truck powered by a virtual driver, powered by the Plus AI driver? Plus is on the cusp of scaling a big global commercial trucking business. The future is bright. The future is autonomous. The future is Plus AI. David, thank you so much for coming on the road to autonomy today.
Thank you.